In this video, I want to look at the graphical representations of the acceleration, velocity, and position all together. Okay, so I have three graphs here, and I'm going to look at the position, velocity, and acceleration and sort of at the same points in time to see how these graphs are related. Okay, so I'm going to start at some positive value of x as my position, and in this first phase, the position doesn't change. It just stays there. So the velocity is going to be the slope of this line. It's the derivative of the position function. So at every point, I'm going to look at the slope of that line. Well, the slope of that line is 0 everywhere. And so I have a straight line at 0 for my velocity, which is telling me how my position is changing, and my position is not changing. And so now the acceleration is the derivative of the velocity, and actually I wanted a different color for that, green for my velocity, and then my acceleration is red. It's also a flat line at 0 because the velocity is not changing. Okay, well, that's not too interesting. I guess one key point here is even though the position is non-zero, the velocity is, because all it's saying is it's not changing. Okay, so now let's say the position is changing. It goes in a straight line to a value of x that's still positive, but lower than where it was before. Okay, and so the velocity at each point is going to be the derivative of this line. Well, it's a straight line, so the slope of this line is the same everywhere, and it's a negative slope. And so my velocity is going to be a straight line of some negative number. Note that here the position is still positive, but since the position is positive and decreasing, my velocity is negative. But I can just look at that mathematically straight from the graph. It's got the line has a negative slope, so my velocity is negative. My velocity, however, is not changing through this entire area, and since my acceleration tells me how my velocity is changing, my acceleration stays 0 throughout. Again, the acceleration is the slope of that line, and that's a horizontal line, so it has a 0 slope. Okay, fine. Let's go back up to where we started in a straight line. So what happens now? Well, I do have a velocity. My velocity changes instantaneously to be a positive number, since I have a positive slope that was sort of equal to the magnitude of the negative slope I had before. So both my position and my velocity are both positive in this case. My acceleration is still 0 because, again, the velocity is constant throughout that region. Now, my velocity changed discontinuously at these dotted lines, and so we're sort of ignoring that sort of instant in time what happened to the acceleration. We're just sort of looking at the regions between these dotted lines. Okay, so let's say my position starts curving. Instead of doing a straight line, it goes sort of a curved position like that. Okay, so my position is certainly changing, so what is this saying? Well, it's sort of right at the slope, pretty close to this dotted line, is pretty close to 0, and then it becomes negative and more negative and more negative as it gets closer to the next dotted line. So if I were to sketch that, I'm going to say, okay, the velocity, which is the slope, starts at 0, but it becomes more and more negative as it comes to this dotted line. Okay, so now I'm going to say, I don't know if exactly, I'm going to guesstimate that's sort of like a parabola, and so the derivative will be a straight line. So it'll look something like this. I know that the slope starts very shallow, and it gets more and more negative as it gets to the next dotted line. So my velocity is changing. So if I'm saying my velocity is changing in a straight line, that means the slope of this line everywhere is the same, and the slope of that line is negative. So the acceleration takes on some negative value that's constant through that entire region. Okay, so now let's go to my position. It's sort of curved around, and now I'm going to say it sort of curves back this way. Okay, so what is this doing? Well, now we're saying that the slope starts pretty steep and negative. It's sort of where it was, but as it goes further, it becomes less and less negative until it's almost zero again. So if I draw that on my velocity graph, the slope starts out of the position graph starts out negative, and then it goes. I'm saying it changes continuously back to zero at the next dotted line. Okay, so if I want to know the acceleration graph, it's the slope of the velocity graph. Well, now I have a positive and constant slope through this region, and so I get a straight line that's positive. So let's look at this. It's sort of interesting. In this region here, my position is positive in this region. My velocity is negative in this region, and my acceleration is negative in this region. In this next region here, my position is negative. It's now below zero. My velocity is still negative, but since it's increasing, my acceleration is positive. And so each graph, velocity and acceleration, is telling you how the other one is changing. And so you have to look to see how the graph is changing to see which one's positive and negative. And remember, in one dimension, the sign is telling you the direction of the vector, whether that vector is pointing in the positive or negative, in this case, say, x-axis. Okay, so let's continue. So I'm going to say my position is sort of curving all the way back to zero like that. So what's happening to the slope? Well, it sort of starts at zero, but now it's becoming positive and more strongly positive as it goes to the next line. So if I were to continue that, my velocity curve might look something like this, where it starts at nearly zero and increases, becoming more positive as it goes to the next dotted line. Okay, so what does that do to the acceleration? Well, I don't think the acceleration graph changes really at all here. There is still a positive slope to the velocity graph through the second region. That's almost exactly the same slope as the previous region, so the acceleration really isn't changing at all. So in this region, the position, this next region, the position sign doesn't change. It's still negative. The velocity sign did change. It's now positive, but the acceleration sign didn't change at all. It's exactly the same, still positive. Okay, and so now that I've got up here, my position is just going to continue in a straight line till it reaches the end. So if it's at a straight line, sort of continuing right where it left off, then the velocity will have the same slope for this entire region. That's exactly the same slope it was when it got to that region. And now, since the velocity isn't changing at all, the acceleration, which gives you the slope of that curve, is equal to zero. All right, so this is a really important skill that you want to be able to develop, is to be able to look at these position, velocity, and acceleration graphs, and to be able to look at one of them and tell what is happening in the others, or be able to take one graph and to be able to draw corresponding graphs given the derivative relationships between the position, velocity, and the acceleration.